Welcome to episode 1 of our Ohm's Law series, where we're going to be getting into series circuits today and how to calculate the voltage, the current, or the resistance on the circuits that you're going to encounter. Remember the packet that was handed out to you in class before we went on lockdown. We're going to be kind of talking about the different equations in there, although we're not going to specifically get into examples that you would have in the packet, but instead I'm just going to kind of cover the principles of what's going on so that way you're able to solve those problems on your own. So by the end of this lesson, you're going to be able to know how to solve for voltage, solve for current, solve for resistance in a series circuit, and you should be able to know the formulas that are required in order to do that. So let's go ahead and get started. Again, with our Ohm's law, we have a couple formulas that we have to know, and the easiest and best way in order to do that is if you just remember this particular object here. Okay, so we have V for voltage up at the top, we have I for current in the bottom left hand corner, and R for resistance in the bottom right corner. And this is going to translate to Ohm's law, which says that voltage is going to equal our current multiplied by our resistance. We can also obviously put down a formula here for current. Total current is going to equal V divided by R. Alright, and then we also have resistance is going to equal voltage divided by current. So up here we can see that voltage is always on top. So if we're figuring out I, we would just end up covering I up. So let me show you what that would look like. So we'd cover I up, and then we have V divided by R. Okay. If we covered up R, we would have V over I. If we cover voltage up, I multiplied by R. So again, just a really quick, easy way to do that, so that way when we run into things. So let's go ahead and draw a very simple circuit wiring diagram here. So I've got my ground, which leads to my battery here. Okay, and then that's going to come, and a wire is going to lead to a load of some sorts, which then is also going to lead to another ground. So when we're figuring out Ohm's law, when we're calculating stuff, we need to have 2 out of the 3 objects in order to do this. So for instance, I would need to have my voltage and my resistance to be able to figure out current, or I'd need voltage and current, which is in amps, in order to figure out resistance, so on and so forth. Okay, so let me go ahead and erase this, and we're going to plug in a couple numbers here just at random, just to kind of walk you through what that would look like. So let's pretend for a second this battery has 12 volts and we have a 10 amp circuit. What is the resistance of this load? So because we're trying to figure out R, we're going to want to end up using this particular formula here. So we would say R equals 12 divided by 10, and that would then equal 1.2 ohms. So pretty straightforward in that regard, so we could erase that and take care of that business there. Let me go ahead and erase this, and we'll figure out for another aspect of this. Let's say we're trying to figure out current on our system. So let's say this is a 4 ohm load. We have 12 volts. What is our current, our amps for this? So again, this time, because we're solving for I, we would use this formula. So it'd say I equals 12 volts divided by 4 ohms. So 12 divided by 4 equals 3, and then we would put amps on there because that's what would obviously be in that situation. Okay, alright, let's go ahead and erase that as well, and we'll show you one more example here before we get into a couple other ideas or thoughts, or in addition to just this. Okay, so let's say we don't know our voltage. Voltage is a question mark. We have amps, so let's say this is a 5 amp circuit, and we have a 3 ohm resistance. So again, this time we would end up using V equals I times R. So V equals I, which is our current, so 5 amps, multiplied by 3 ohms. Okay, 5 times 3, 15, and then we would put V for volts there. Alright, so that's how you would use those three formulas to figure out, based off of 2 out of the 3 pieces in a circuit. Alright, so let's get a little bit more complicated here. Let's say instead of just a single load, we're going to have 2 loads. So we have a load there, and I've got a load there now. Okay? What does that entail in regards to trying to figure things out? Well, we're still using the same formulas. However, this time we are going to look at some additional things that is going to be included in our circuitry formula. So, for instance, with our series circuit, our total voltage is always going to be voltage 1, voltage 2, voltage 3, voltage 4, etc., etc. And then I believe we are then going to have our resistance, kind of same thing. Total resistance is resistance 1 plus resistance 2 plus resistance 3. You get the idea. Okay, so remember, this is going to end up being in a series. Alright, so let's go ahead and play with this around a little bit. So for instance, we have 12 volts here, we have 2 ohms there, we have 2 ohms here. What is our current going to end up being? Okay, so again, since we're figuring out current, that's going to lead us to the I equals V divided by R. So our I, and I'm just going to put a little T down here to indicate we're trying to figure out total current in our circuit, equals our 12 volts, and that's our total, divided by our total resistance. And here you can see that our total resistance is R1 plus R2 plus R3. So this one here, let me get a different color quick. So this is our R1, this is our R2. Okay, so if I come in here, I could in theory put in parentheses R1 plus R2. Alright, and then we would just end up solving the formula. So 2 plus 2 is 4, so it would be 12 volts divided by 4 ohms. So in theory, this circuit, even though it has 2 loads, one at 2 ohms and the other one at 2 ohms, it acts as if you had a single 4 ohm load in the system. And then we just divide that out. So 12 volts divided by 4 ohms equals 3 amps. So our amp total is going to end up being 3. Okay, let's go ahead and erase that. And we'll do one more kind of to give you an idea of what this might look like. Let me get my eraser tool out here. Alright. Let's pretend for a second that we had a 10 amp system, 10 amp current in our 12 volt battery, and we had a 2 ohm resistance here, but our second resistance, or resistor here, we don't know what that load is on there, so we can calculate that as well. So again, going back to this, I'll select a different color here. We're still trying to figure out, let's see here, instead of using this, we are going to be using that formula because we're trying to figure out R. So we want to figure out R equals 12 volts, remember this is total R, divided by 10 amps. Okay, and I can even go even further on this. I could say R total, right, is R1 plus R2. So I could, in theory, put a parentheses. We know what R1 is, 2 ohms, plus whatever R2 is, that is our variable, equals 12 volts divided by 10 amps. So now we can do the math according to what we know. Okay, so 12 divided by 10, again, that's going to lead to 1.2. And then obviously we have 2 plus R. So what we do on one side, we have to do on the other side of our equation. So in this case, I'm going to subtract 2. Okay, and what that ends up doing is neutralizing that 2. So let's see here. We're going to have, that doesn't make too much sense. So our resistance is going to equal negative 0.8. Huh. Probably could have used a different example on that one to be able to figure that out. But that's how you would essentially do it, right? You would take our total, which is down here, and just substitute in however many R's or resistance you have in the circuit, and then essentially you're going to solve for this variable right there in order to get what that is. Okay, and this is going to be series circuit, so the formulas are pretty much going to act the same and going to be going through the whole thing. So what did we learn here today? Well, we learned that we have 3 different formulas for our Ohm's law, and we just apply each one of these according to which variable we want to find, whether it's voltage, current, or resistance. And then we also have to keep in mind the number of resistance that we have in our circuit, and then we can either apply our total resistance or our total voltage if we have multiple voltage pieces in it, which is not typically what you would find in a vehicle. So if you have any questions, feel free to email me or shoot a private comment out in Google Classroom. Otherwise, we'll see you guys on the next episode.